Welcome, this is Professor Ridge, and today's lesson 9.2, Arithmetic Sequences. And our first learning objective for today, find the common difference for an arithmetic sequence. Alright, so let's define an arithmetic sequence. An arithmetic sequence is a sequence that has the property that the difference between any two consecutive terms is a constant. This constant is called the common difference. If a sub 1 is the first term of arithmetic sequence and d is the common difference, the sequence will be a sub 1 plus d. Then you're going to add d again, so you get 2d. Then you add d again, you get 3d. Okay, so for instance, if I wanted a sequence, let's say my first term is 5. Okay, so sequence A is, let's say 5, and the common difference is 3. I'm going to do 5 plus 3 is 8, and just keep adding 3. 8 plus 3 is 11. 11 plus 3 is 14, so on. So D would be equal to 3, and that's the common difference. And notice if you subtract 8 minus 5, you get 3. 11 minus 8. 14 minus 11. See, and that's why it's called a common difference, because if you take the difference of any two consecutive terms, you do the latter one minus the one right before it, you're going to get this constant. Okay, so example 1, find the common difference in each sequence arithmetic? If so, find the difference. Find the common difference. Alright, so you have to check that you get a common difference. So if A1 is 1 and A2 is 2, A1 or A2 minus A1 is 1, and then if you do A3 minus A2, you see we get 4 minus 2, which is 2. So no, this is not arithmetic. Okay. So B, so if you subtract 1 minus 3, so for B, 1 minus a minus 3, that equals 4. And then if we do the next one, 5 minus 1 is 4. And then the next one, 9 minus 5 is 4. And then 13 minus 9 is 4. So you see how they're all the same? They're all common. So yes, this is arithmetic. And D is equal to 4. Okay, the next objective, write terms of an arithmetic sequence. Writing terms of arithmetic sequences. Now that we can recognize that an arithmetic sequence, we find terms if we are given the first term and the common difference. So you just basically, you're going to start with the first term. Second term, you just add whatever the common difference is to the first term, and then you just keep adding that number repeatedly. In addition, you can also do this general form. If you know it's arithmetic sequence, this is the general term of an arithmetic sequence given the first term and D, the common difference. Okay, so let's write the first 5 terms of the arithmetic sequence with the first term being 17 and the common difference being -3. So remember, you're going to add the common difference first term to get the second term, and then you keep doing that, repeat that until you get the desired number of terms. Alright, so the first term is 17. So basically this is like a recursive formula. So A2 is going to be A sub 1 plus negative 3. So 17 plus negative 3 is 14. And then we're just going to add negative 3 to that one. So that would be A sub 2 plus negative 3, which is 14 plus negative 3. So you just keep adding negative 3. So you get 11. And then A sub 4. Okay, I'm not going to write this. It'll be 11 plus negative 3, which is 8. And A sub 5 would be 8 plus negative 3, which is 5. So our first 5 terms of the sequence will be let's see, we start with 17, and technically you don't even have to show all that work, right? You just do it. It's just 17 plus negative 3 is 14, plus negative 3 is 11, plus negative 3 is 8, plus negative 3 is 5, so on. And that's it. All right, example 3, writing terms of arithmetic sequences. So given A1 is 8 and A sub 4 is 14, find A sub 5. So basically we need to figure out what D is so we can get A sub 5. And from our general formula for an nth term of an arithmetic sequence we have up here, we're going to substitute those values in and solve it for D. So we know A sub 1 is 8, A sub 4 is 14. So let's see, A sub 4 is 14, A sub 1 is 8. Okay, we're plugging it into the general formula. Listed above there. Okay, so A sub 4 is 14, so I put that here, but N is 4, the subscript. That's the 4th term. So we do 4 minus 1 is 3. I'll just go ahead and write 4 minus 1. And then D, we just got to solve this for D. So we get 14 equals 8 plus 3D. And in just simple algebra now, we're going to get D by itself. So you can see D is 2 when you solve it for D. So now that you know D is 2, to do A5 you can plug it in this formula, or I could just add 2 to A sub 4 to get 15. So A sub 5 is 8 plus 5 minus 1 times D. D is 2. So 8 plus 4 times 2, which is 8. 8 plus 8 is 16. Right? Remember I said we could have said, or A5 recursively is A4 plus the common difference. They didn't give us that formula, but that is a formula, right? We can build arithmetic sequences recursively by saying A sub n is A sub n minus 1 plus D, and from this formula we can actually build this general term formula. So A sub 5, A sub 4 was 14 and D was 2, and you get 16. So you could do it either way. I probably would have done it this way because, right, it was next to it, but let's say I wanted to find A12, A sub 12, then I would use the general formula. And that brings us to the next learning objective, which is going to show you the recursive formula for an arithmetic sequence. So you want to be able to use a recursive formula for an arithmetic sequence. Okay, so here's the recursive formula for arithmetic sequence common difference D. It's the nth term, A sub n, is equal to the previous term, A sub n minus 1, plus your common difference, D. And so if you're given the first term, you just keep repeatedly adding your common difference to get the next term, to get the next term, so on. Okay? So, example 4, write a recursive formula for the arithmetic sequence. So basically what we need to do is figure out what the first term is, or we need to know what D is. And then we also have to, you're supposed to state what A sub 1 is, right? Because this is in. All right, so let's figure out D. So basically, if you're told this is an arithmetic sequence, you can just take any two consecutive terms. See if you subtract A sub n minus A sub n minus 1, that's D, right? You take any two consecutive terms and subtract it to figure out D. So I can do A sub 2 minus A sub 1. So negative 7 minus negative 18. So that is 11. And you can see if you add 11, you get to 4. Add 11, you get 15. Add 11, you get 28. So you can see that D is 11. And now you can say A sub n. Well, first remember to write recursive. I have to tell you A sub 1 is negative 18. And then I can tell you A sub n is equal to A sub n minus 1 plus D for n is greater than or equal to 2. So basically that would be your recursive formula. All right, and then the last learning objective, use an explicit formula for an arithmetic sequence. Okay, so the explicit formula for the term we have already discussed, but here it is again, A sub n. So the general term, or the nth term, is given by, you take the first term, you add D times n minus 1. You can actually switch the order of these two terms, the D in the parenthesis. Given the first several terms for an arithmetic sequence, write an explicit formula. So first you got to figure out D, then you substitute the common difference first and the first term into the formula, and then you solve it. Okay, so writing, actually you just substituted the A1 and the D, and then you have the explicit formula, right? We want to write the explicit formula. So first figure out D. So D, remember, is you can take any two terms. So it's typically we do the second one minus the first one. And so 12 minus 2 is 10. And then I always just check real quick. Am I adding 10, adding 10, adding 10, adding 10? Yeah. Okay, so that's D. Now we can write the formula. A sub n is A sub 1, which is the 2, plus D, which is 10. Then n minus 1. And that's it. Okay, I was looking at the answer. That's actually typically I leave it like that, but you know, sometimes you like to simplify things. So if we do a little algebra, right, distribute the 10 and then combine like terms, and we get 10n minus 8. So you can kind of think of it as a linear equation almost. Well, it is, technically. Okay, example 6, finding the number of terms in a finite arithmetic sequence. Find the number of terms in the finite sequence. So we got the first three terms, 8, 1, negative 6, then the ellipse, dot, 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 and then negative 41. And we want to know how many terms is that. So we can't see how many are in this and so on portion here. So the technique then is first figure out D. Okay, so D is equal to 8. Oh no, sorry, we're subtracting the latter one minus the it's A2 minus A1, which is negative 7. And then you're going to substitute that into, and the first term into the general term. So A sub n is, let's see, A sub 1 is 8 plus D, negative 7, and then n minus 1. And then you're going to substitute in the number for a sub n, and we're going to solve it for n to figure out what term in the sequence so we want to put negative 41 in here for a sub n. Okay, I'm going to go ahead and distribute that. So it'll be negative 7n and positive 7. Combine my like terms. 15 minus 7n. Subtract 15. So that gives me, what, negative 56. And then divide by negative 7. So n is 8. So negative 41 is the 8th term. Or let's see, find the number of terms. There are 8 terms in the sequence, right? That's fine. There's 8 terms. Example 7, solving application problems with arithmetic sequences. So a 5-year-old child receives an allowance of $1 each week. His parents promise him an annual increase of $2 per week. Write a formula for the child's allowance in a given year. Okay, so A, we say A sub n for the allowance is going to be 1 plus 2n for each year after being 5 years old, right? So it starts out as 1, and then the next year will be 3, and the next year will be 5, so on. What will the child's allowance be when he is 16 years old? So let's see. We started at 5. So that would be in 11 years. So we want to know what A sub 11 will be. So 1 plus 2 times 5, right? Because 16 minus 5 is 11. And then we get what's that, 11? Oh, I was supposed to put 11 there. Sorry about that. 11. So that will equal 1 plus 22, which is $23. So the child's allowance will be $23 when he is 16 years old. His allowance will be $23 when he is 16 years old. Let me add a little more detail here. So we're saying n is 1 when the age is 5. And then A sub n was 1. Actually, that doesn't make sense, huh? 6 would be 2. This would be 3. Because if you put in 1 in here, that would be 3 for his allowance. So actually, this should be 0. This should be 1. And then 7 is 2, 8, 9 is 4, 10 is 5, 11 is 6, So you can see 11 minus 5 would be 6. Oh yeah, that makes sense. So 10 minus 5 would be 5. Okay, so if we go to 16, 16 minus 5 would be 11. Okay, so we did it right. Just wanted to double check that. 5, 7, 11, 13, 15, then be 23. Okay. All right, that brings us to the end of the section. So again, practice, practice, practice. Go to the end of the section, do the exercise set there. All the odds, you know the drill. If you need to do some more, do some of the evens, but make sure you practice and understand these concepts. Okay, have a great day.